Okay, before we continue, we're going to need another derivative, and this is a derivative that I'm not going to be able to define because it is defined by a process of integration, which we haven't learned yet. But we do need to borrow a formula from that, and that formula is the derivative of the natural log of x. And we're just going to have to take this on faith right now that the derivative of the natural log of x is 1 over x. So when f of x is ln of x, the derivative of that is 1 over x. And we're going to use that and now to derive some, to come up with some further derivatives for exponential type functions. Okay, so I've written in red the two derivatives that we have introduced in these couple of videos so far. And we're going to build on them to find some other related exponential and logarithmic derivatives. And we know what the derivative of e to the x, that is the exponential function with a base e, and e being 2.718. But if there were a different base there, any other real number as the base, would it be the same? Would it just be the derivative of a, where a is any real number, to the x is just a to the x? Well, what we're going to do here is use a process called logarithmic differentiation. And the process of logarithmic differentiation works this way. The first thing we're going to do is, instead of using f of x is equal to a of x, that is the function we're trying to find the derivative of, we're going to rewrite it as y equals a to the x. So then the first step is to rewrite as y equals whatever the function is. Second step is that we're going to take the natural logarithm of both sides. And let's see what that looks like. So we have natural log of y is equal to the natural log of a to the x. Obviously, if two quantities are equal to each other, then the natural logs of those two quantities will also be equal to each other. And we're going to use our properties of logarithms to bring down the x. So we use our properties of logs to rewrite the natural log of a to the x. If you recall, when you have natural log of some uh, of a number raised to a power, then that power can be brought down and become a multiple. So ln a to the x is the same as x times ln a, and I won't get into the properties there, but you should remember this from pre-calculus days. The next thing we're going to do is take the derivative of both sides with respect to x, and I write WRT, which means with respect to x. Now, based on what we just learned, the derivative of the natural log of a number is 1 over that number. But because this is the variable y, actually I should say the natural log of a variable is 1 over that variable. But since we're differentiating with respect to x, we still have to treat y as a function of x. And so we have to multiply the resultant 1 over y by the derivative of y, which is y prime. Now on the right side, we have x times ln a. Well, you have to remember that the natural log of a being some constant, is just a constant itself. And so what we really have here is nothing different than 2x or 3x or 4x. And so the derivative of 2x would just be 2. The derivative of 4x would be 4. The derivative of natural log of a times x is just the natural log of a. And the next thing that I'm going to do is rewrite or multiply both sides by y, and I get y prime is equal to y ln a. But if you recall that y is equal to a to the x, we can substitute a to the x for y, and we get the derivative with respect to x of a to the x is a to the x times the natural log of a. And you might see that when a is equal to e, when a happens to be the constant e, then the natural log of e is 1, and you would get e to the x times 1, which is e to the x. So the derivative of e to the x is a special case of what we just did here. So I'll add this as a formula. And so now we have 3 new formulas on this page here, and we will add another one, which is how do we find the logarithm of a base other than e? How do we find the derivative of a logarithm with base other than e? And we'll begin that in the next video.